All right, the second question. The second question, let's go through it and read the question together and see what is it asking us. How effective is washing your hands in eliminating bacteria? A researcher tests 4 different methods: washing with water only, washing with regular soap, washing with antibacterial soap, and spraying hands with an alcohol spray. For 32 mornings, she washed her hands according to one of 4 methods, 8 mornings with each method. She then placed her hand on a styro media plate designed to encourage bacteria growth. Each plate was incubated for 2 days at 36 degrees of Celsius, after which the number of bacteria colonies were counted. Okay, the data is shown below. All right, so we've got 4 different groups: alcohol spray, antibacterial soap, and water. And we've got here 8 observations for each of them. So what the question is asking us? So the question is asking us, produce appropriate graphical displays to compare retention rates between 4 groups: alcohol spray, antibacterial soap, and water. Based on the graphical display, compare the performance of each washing method. So, what do we need? What is the appropriate graphical display? Here we've got 4 different groups, right? 4 different groups. These groups, because we've got 4 different groups and which are categorical, so we've got categorical, variable, those 4 groups, and a numerical variable. What is that numerical variable? The number of the bacteria that grow. Okay? Bacteria. Number of bacteria. Alright? So because we've got a categorical and numerical variable, the best thing is to use a side-by-side box plot. So to do that, you can go to the SPSS and generate this side-by-side box plot. So many students in here, they don't, once they generate it, they don't compare the results. What we want you to tell us, we want you to tell us what is the difference between the means of these 4 groups. Which one has a greater mean? Which one has a smaller mean? That's what we want you to tell us. Okay, so that's about the part A. So in part B, it's asking carry out an appropriate hypothesis test, again at 5% significance level, to compare the different methods of hand washing. Make sure to report the hypothesis tested, test statistic, null distribution, p-value, and conclusion in plain language. So what are those values? All right, you need to carry out this hypothesis test with SPSS. Once you carry out this test with SPSS, you will have this output in here, okay? But before going through this table, I want to explain what is the null hypothesis and alternative hypothesis. So this is a little bit tricky. Many students have problems in writing the null hypothesis and alternative hypothesis for ANOVA. How do we write it? In ANOVA, we've got this H null and H alternative. In ANOVA, we normally have more than 2 groups, right? So imagine in here, we've got 4 groups, right? A, B, C, D. Let's represent them with A, B, C, and D. So the null hypothesis is testing the mean of A is equal to mean of B, whether the mean of A is equal to mean of B, mean of C, and mean of D or not. Okay, that's our null hypothesis. We want to test that the mean of all these groups are equal. And the null hypothesis is testing that if any of these 2 groups do not have equal mean. So we can write it either verbally or mathematically? Let's write it first verbally, and then I will explain it. What is it mathematically? So verbally, that would be if any of these two groups, any two of these groups have different mean. Okay, that's what we need to write. We can also write this in mathematical term. In mathematical term, you can write mu of I not equal to mu of j, and I and j are all in A, B, C, D. Okay, so you can replace I with any of them, and you can replace j with any of these values. That's how you write the null and alternative hypothesis. Let's proceed with the question. That's the null and alternative hypothesis. What is the test statistic? The test statistic is given in here. That's for the methods we want is F. What is the p-value? The p-value is here, significance. So the significance is actually showing the p-value. All right? That's the test statistic and p-value. What is the null distribution? So the null distribution for ANOVA is null distribution is F with k minus 1 and n minus k degrees of freedom. This is important to report, okay? We want you to report both of them. They are the degrees of freedom that we have. K is the group. We've got 4 groups, so that would be 3, and n minus k, we've got n is the number of observation and k is a group, so that would be 32 observation minus 4, that would be 28. That's our null distribution if H null is true. Okay, what else? We wanted to test, we wanted to figure out the p-value, which is 0, as you can see in here. And what is the decision? We reject the null hypothesis. The p-value is equal to 0, which is not actually 0, but it's something like that. It's smaller than 0 with 3 decimals. But let's consider just this one. Don't go with this one. Let's consider that the p-value is 0. That means because it is smaller than 0.5, we reject the null hypothesis. We reject the null hypothesis. Okay, that's about it, the first one. Don't forget to interpret your result to give us a conclusion whether you reject or do not reject it. All right. That's about part B. What is part C? Part C is asking, if appropriate, carry out post hoc test at 5% significance level and report the results referring to relevant output. If post hoc testing is not appropriate, if it is not appropriate, explain the purpose of post hoc test and why they are not appropriate in this example. So when do we do a post hoc? Very easy. When we reject the null hypothesis, we reject the null. That means we need to do the post hoc analysis. Why? Because when we reject the null hypothesis, we say that there is a difference between the mean of these groups. Right? The mean of A, B, C, there is a difference between them. We want to figure out which means are different. That's why we do the post hoc analysis. Okay, so the post hoc analysis, if you do the post hoc analysis with SPSS, you will get such a table. Here, I want to explain what do they mean. How do we interpret the results? I'm going to circle 3 areas. Here, significance. Here, confidence intervals, and here, just here, the subsets that we have. How do we interpret that? Let's start with the first area in here. What we do, simply look at the significance value in here. That's telling us the p-values, right? And highlight the ones that the p-value is smaller than 0.05. That's a smaller, that's a smaller, that's a smaller, that's a smaller. The rest of them, the p-value is greater than 0.05. So that means the highlighted parts, the p-value is smaller than 0.05, and we reject the null hypothesis. Okay? We reject the null hypothesis. That means, let's look at this. This p-value corresponds to the comparison of water and alcohol spray. That means there is a difference between the means of these two groups. This p-value in here corresponds to the water and antibacterial soap. And that means there is a difference between these two. Okay? And these two values in here are the exact same thing that we had up there. It's alcohol spray with water and antibacterial soap with water. So these are actually what we tested for them up there in here. We just have more, we just got them here again. That's one way to find it, to find the significance, to find which groups have different means, right? The second way is by looking at the lower band, upper band. So the lower band and upper band, if they do not include 0, reject the null hypothesis. This doesn't include 0, both of them are negative value. This doesn't include 0, this doesn't include 0, it's all positive, and this doesn't include 0, all positive. All the rest of them, if you look at them, they include 0. For example, this one, 0 is between these two values. 0 is here, 0 is here, 0 is included in all of them. So they are the parts that we do not reject the null hypothesis, okay? But yellow part, we reject the null hypothesis. What else we've got? The third area in here, down there, here. Here again, we've got two subsets. The SPSS is telling us, is giving us the answer actually. We've got, Okay, we've got here and we've got here. These two subsets. That means these groups that we've got, group 1, the mean between them is the mean is not significantly different between them, and in the second group the mean is not significantly different between them. And this actually verifies the answers that we had up there, because if you look at it, we can see that soap and water are in the same group here. Soap and water are in the same group, as you can see, and here soap and water, for example, there is no significant difference between them. The p-value is smaller than, and the p-value is greater than 0.05, and the confidence interval includes 0. That's all about the post-hoc analysis that you need to know. So to sum up, we've got 3 ways to find whether, to find which groups have different means. Okay. The third part of this question was just what I explained. And lastly, the question is asking what are the assumptions of the hypothesis. I again suggest you to write these assumptions in your cheat sheet if you can remember them, because they are important when you are carrying out the test. So what are the assumptions of this? The assumptions of ANOVA, we've got 3 assumptions. I'm going to list them here. 1, observations are independent within each group. We've got 4 groups. The observations, they should be independent. Are they independent? just go back and look at the question and see if there is any information given to us they are independent or not. If you look at the question, we haven't really give you any information, and we can't really interpret them and to find a reasonable answer to say they are independent. So you can simply say we haven't given any information and this assumption may not be met. The second assumption is the variances of each group is equal. How do you do that? Use the Leven's test of equality. So the Leven's test, you can carry out this test with the SPSS, and then once you do that, you will get a table like this in here. So the table is giving us Leven's test of equality of variances. The null hypothesis, note that the null hypothesis is the variances are equal. Okay, the null hypothesis. And the p-value that we've got in here is here, 0.430. The p-value, the p-value is greater than, p-value is 0.43, I guess. That's greater than 0.05. Do not reject null hypothesis. What was a null hypothesis? Null hypothesis, variances are equal. Variances of each group are equal. All right, that's about the second one. The third assumption, what we want to test is each population is normally distributed. In order to test this assumption, you need to plot. You need the QQ plot. Once you generate this QQ plot with SPSS, you will get you will get this one first. This is for all the observations, and all of them lie around this straight line, which shows us that they're actually normally populated. But we need also this one. This is the important. We've got each group in here, right? So we've got each group, and we see all of them lie around this straight line. So we can say that they are normally distributed. Okay? This is about the second question. Please let me know in the comments below if you have any question, and we will go through the third one now.